Hello everyone. Welcome to another session with me. This is a course which we are doing called Introduction to JavaScript by Anirudh Agarwal. And just to give for people who are coming in new, just to give you a brief introduction of what this course is. This is a initiative by Newton School for people who have little or no experience with programming to just yeah. So as I was saying, this is the course that this is the initiative by Newton School in which we have developed this. We have taken up this course for people who have very little experience, just to get them to know about what JavaScript is and develop an interest in programming in general. This is not a very full-fledged course, and but we have tried to cover all the basics of JavaScript. And so in the previous lectures, this is the eighth session we are doing today, but there are 7 sessions in which we have talked about what JavaScript is, how is it different from other programming languages, what is a function, what are loops, what are conditionals, how can JavaScript be used as a functional programming language, how is it an object-oriented programming language, what are classes, and this course has not been very limited to JavaScript, but it has also tried to cover a lot of concepts around object-oriented programming in general, and not just related to JavaScript. So this course will give you a very good introduction to what programming in general is like, right? So yesterday we left off with we were talking about polymorphism, inheritance, and we talked about a lot of object-oriented programming language constructs. And today what we are going to be covering today is we are going to be continuing with polymorphism, and then probably we'll talk about again go back to inheritance, and we'll talk about another very important concept when it comes to inheritance called super keyword and the super function, right? So that is what we are going to be covering today, and then we'll see a few more object-oriented programming concepts in depth, right? So just to continue, and just to give you a brief, we had discussed yesterday. The last topic that we left off was polymorphism, right? So polymorphism is basically one name, many forms, and I gave you a very stupid example about the air conditioner, right? And now the next example that we have been that was more of that was just an example, right? And then we talked about compile time polymorphism, wherein if a function is passed various values, like if it's passed in integer, JavaScript is intelligent enough to understand that whether when it's integer, it actually has to add those numbers. So if we pass 1 and 2 as parameters to a function, what it will do is that it will add and return a result of 3, right? And instead, if we pass it a string, what it will do is, and if we pass a string like A and B, it won't add those numbers. So ideally, if you look at it, the logic should have been that it should have added the ASCII values, right? So a number is actually, and everything in computer science, everything, even a number A, B, C, whatever we write, right? Everything is actually represented in forms of bits, right? At the end of the day, everything is either 0 or 1, right? So ideally, what JavaScript should have done is that it should have added those bits and should have given me a bit number or some junk value, right? But it was intelligent enough to figure out that A plus B gives, and it returned me a value of AB, right? So that is polymorphism, which JavaScript is intelligent enough, and that is happening at compile time. And then we talked about polymorphism at runtime, wherein a class, wherein we had a parent class in which the parent class had a function, and then if it was if the and if that class was inherited or inherited, or or some child classes are extending that particular parent class, and the same function is also written in the parent class and the child class. What happens? We talked about that. What is it that called? What is method overloading? What is method overriding basically, and how. We'll just take a look at some examples, and then I think that will make things very clear for you. for us, right? So let's go through this again, and we'll say we'll take a class, and we'll take a class called car, and we'll define a function here called move, right? And in this, what we'll say is that we'll say console.log, and we'll say car is moving, right? Let me zoom the screen a little, and then let me define another child class. So I'll say race car, and I'll extend it with a parent class. And I'll define the same function, right? And I'll try to override that particular function. And now we'll see, and I'll say console.log of race car is moving, right? This is what we'll define. And then when we say, so let's do this, right? So let's do, I'll create an object of car class. So how we'll do that? I'll say var of car1, and I'll say new car. As a car1 dot move, right? And that is what we'll do, and we'll see the output of it. Meanwhile, it is running. What we'll do, so yeah, the output is there, and its car is moving. We are able to see the output, right? Whatever is required. Then we'll see var car. We'll say race car1, race one, and we'll say new. Cool. So there's no polymorphism in this, right? It's just very simple logic that we have put in, wherein we are saying that, okay, so if it is a car, if here there's no polymorphism at all, and we are saying that, okay, there's a car and it's a function, and we're able to run it. Till here there's no polymorphism involved, right? And but when we define a car, when we define another class called race car, and we extend it via its parent class, right? So now JavaScript would be confused, right? That what should it do? So what JavaScript does is that at compile time, it does not look at any of it, and what it does is that basically at runtime, right? When it sees the code, what it sees that whenever it sees that, what it sees that it will see that, okay, if car is there, parent class, so it will first look at all the functions of parent class, but then it will see that, okay, there is another function in the child class which has the which has the same function as the parent class, but it's given a different body, right? So what it does is that it overrides that particular functionality, and that so basically why is it called overriding? The term overriding comes because the functionality provided by the parent class is overridden by the child class, by the child of car, which is race car, right? So the functionality is overridden in that way. So that is what we have been doing, and that is what it was able to override, right? So this is what is polymorphism. At runtime, it was able to figure out that, okay, the child class has the same function as the parent class, so it will basically overridden that functionality. Now, just to mention that another functionality or another construct of this guy, right? Basically, it is that the one thing that I want to mention is this is actually all of this overriding, right? It is so important for us, right? So just to understand it, it might not seem very useful for now, because we are taking very trivial examples, right? But if you look at it and if you imagine about it, what is it that's actually happening, right? So if you imagine, just think about, I'll give you a very, very simple example, right? So basically JavaScript provides a lot of inbuilt classes, and basically you might be using a lot of libraries, right? So let's take a very simple example of a mouse pointer, right? So if there's a library which is basically telling you that, okay, when the user is actually so when somebody would have been writing some drivers around drivers of your mouse, right? So basically your mouse, when it's running, right, when I do a left, when I drag my finger to the left of my keyboard, my pointer has to move towards the left, right? And when I move towards the right, it has to move towards the right? So let's say tomorrow I am trying to write a program which is actually called an invert, right? And I do a software. I want to write a software which is actually doing the invert. So when I drag my finger towards the left, my cursor should actually move towards the right, and when I drag my finger towards the right, it should actually move towards the left. So that's what I'm trying to do, right? So in that case, imagine how would you have gone about solving that? You would not have, right? It would have been very difficult for us to solve, right? And just remember this example. We will be using this example particularly for the super explanation, the next topic that we're going to be picking up. So just try to imagine that. And what I'm saying is that so how would I have to do that? So let's say there is a class, right? So just imagine that there would have been a class called mouse pointer, something of that sort. And let's say and then there would be a function called drag left, right? And we'll do a console.log of we'll say mouse drag left, right? That is what we can do, right? And then we can also do drag right, and similarly we can do console.log of mouse dragged right, and then so basically whenever the user is actually, when the user actually pointing towards the left, he's moving his fingers towards the left, what we'll do is we will invocate this function, and it will, this is the actual implementation which was given to us by which is actually there, right? Is the implementation. So basically it would have been implemented somewhere in the OS, right? And if you're using Windows, then the OS Windows OS would be doing that. If you're using Mac, then the Mac OS would have written a class something of this sort, right? And then but since I'm writing the invert functionality, right? So what is it that I have to do now? If I have to write, right, what I'll have to do is I'll say class invert mouse pointer, and then we can say that drag left, and we can do console.log of let's just copy this. I'm very lazy, so let me just copy this, and I'll say drag right. So this is basically what I have done this, right? And now you would say that what is the use, right? But the use of the mouse pointer is that there are multiple functions, right? It would not just contain these two functions, drag left and drag right. It would also contain a multiple, right? It would have thousands and millions of functions in. Probably this class would have millions of functions inside it, right? Million is a very, very big number, but there would be around, I'm very sure that there were hundreds or thousands of functions inside it. But I just want to play around with the functionality of these two functions, right? So so whenever I'm using my mouse, right, I want all the other functionalities, and I just want to change the functionalities of these two functions. So that is what I'll have to do is I'll extend with mouse pointer, and that is what I'll do. So basically it will inherit all of these functions that are there, and only the functionality that I want to change will be overridden. So why did I tell you all of this? This is to understand the use case of using all of this, right? So the use case of why function overloading is very important. So most of the time software developers know how things are done, but it is very important. It is very important for us to first understand that why is a thing required, and then how is something which we can later tackle on. But why, what is the need of a particular functionality? What is the need of function overriding? What is the need of polymorphism? So that is what this particular thing will help us understand, that particular thing, right? Now having understood all of this, now let's imagine this logic, right? What did I just do? Right, what did I just do? I just copied, right? So I copied the function body which was there. Now since we are taking it as a trivial example, but what in actuality and in real life code, what would be there? There would be a complex logic around here, right? And drag right would also have some complex logic around here, right? There would be some logic which will be performing calculations that how much the user has dragged, what is the speed of the drag, with according to the speed of the drag, how much the pointer has to move, what all pixels does it have to display, and all of that logic would have would already be in there, right? So what in actuality, if I was doing, what would I have to do is I would have to copy this particular piece of code, and exactly that is what I did, right? But imagine that this and what did we learn? What have we what is object oriented programming? What we have been learning till now is that it is not a good practice. It is not a good practice to duplicate our code, right? It's not very good to have duplications, and if you want to go, if you have some bugs, then you would have to solve in multiple places, all of that, right? So we are always trying to figure out smaller ways, right? To and to figure always trying ways to figure out that how do we remove our code duplication, right? So what is it that I would have to do, right? So instead of me copying this entire body, what if I can call some functionality of my parent class, right? What if I can call the functionality of this particular parent class, right? So just to do that, right? So in your child class, if you are overriding something, but you also want to invocate the body of your parent class, right? If you want to refer or call a function of your parent class, what JavaScript does is that, and again, this is not a construct which is just provided by JavaScript, but it is a construct which is provided as it's a construct of object-oriented programming. So this is something called a super keyword, right? And super is a keyword which is used to refer the parent class. So what we can do is that instead of doing drag left and instead of copying this entire body, what we can do is that now that we know that whenever the user is actually dragging left, you want to invocate the functionality of dragging right, the user dragging right. So what we can do is that we can do super dot drag right. So what this guy will do is that whenever the drag left function is called, it will actually invocate the parent class functionality of the it will call the parent class functionality of this particular function, right? So this is what super keyword is used for. And similarly what we can do is that we can do super dot drag left, and we'll see it in practice once. We'll run the code. Let me remove all of this, and then we'll sudo new. Let me define a variable, and I'll name it inverted, and I'll say new inverted pointer mouse, right? And then we'll say inverted dot drag left, and we'll invocate this function. See, so we called mouse dot drag left, and actually what it did is we called super dot drag right, and it printed this particular mouse drag right. So that is what it did. It actually invocated the parent class. Instead, if we would have done this dot drag right, it would actually have called this particular function, and this would have called drag left, and this drag left would have mouse drag left. So it would have called this. But instead, what did we do? We called super dot drag left, which is actually refer to the parent class of this. That's it. That's what super keyword is used for. Now another use of super keyword is this is another use of super keyword is to refer to the parent class variables, right? So so let's say let me define some functions, right? And let me define a constructor first. We'll do console.log, and we'll say mouse pointer constructor, and we'll write a constructor here also. Inverted mouse pointer constructor, right? So now let's see what happens. Let me just try to run this, and we'll see. We should see that what is happening. Right. So yesterday we talked about that we talked about a concept called constructive chaining, and ideally what should have happened is that that the constructor of the parent class should have been called, right? So we saw all of that happen in action, right? But the thing that we missed yesterday And probably some of you might be thinking that why is it that it was not printed? This particular console line was not printed, right? And this is, and there's a reason behind it. So one thing that gets missed very frequently is that there is an error which is also generated. So there's a standard output which is generated, and there was an error also which was generated. And what does it say? Must call super constructor in derived class before accessing this or returning from derived constructor, right? So what does it mean? It says that must call super constructor in derived class. So must call super constructor. So what it means is that it should call super constructor. Super constructor means the parent constructor in the derived class. So this is the derived class because the child class is also called a derived class. And before accessing this or returning from derived constructor, right? So ideally, what JavaScript always needs is, right, whenever we are using inheritance, one good practice, and even though this function works perfectly fine, this particular piece of program works perfectly fine, but the thing is that it also results in an error, right? And that error is this particular error, and it does not work the way it should. It is not following all the true principles of object-oriented programming. And the principle that it is violating is the constructor chaining principle, right? That is very important. So what if there were some important initializations that were happening, and it makes sense, right? So this mouse pointer class would have had a lot of logic which would have been written inside the constructor of this particular class, and it would have made a lot of sense. It would have made a lot of sense for the developers to have actually written this constructor, and written a lot of initialization in this constructor. So we should actually be invocating this particular constructor, right? So there are a lot of languages like TypeScript. We talked about TypeScript yesterday, and all of this happens by default. But JavaScript is while writing in JavaScript, what is it that we have to do? So is to have to we have to invocate the super constructor of this, right? So, and that is what will, and it the JavaScript also gives us an error, right? That you are doing something wrong. There's something wrong with this particular, when you're writing this constructor. What is it that you're doing wrong? What you're doing wrong is that you are actually calling this super constructor. You're not calling this super constructor, and that is what we are doing. Now we'll see this in action, and this particular error should get removed, right? And then now we should be seeing the proper constructor chaining principle in action, wherein first the parent, right? So and imagine a case wherein this mouse pointer was also extending some class, and let's just give it an example, and I'll say class. Oops, my bad. Right? So yes, right. So basically, what happened is, first this guy was called, and also if you right. So let's just take it one step at a time. And one thing that I wanted to mention is that, let's say I have a class called parent. This is the parent, and let's just give it some random name, super parent, right? And I'll give it a constructor, and I'll say console.log of super parent, right? And let's just do this. And if extends super parent, right? So instead, now the same constructor chaining principle would have to be followed, right? So the parent of inverted mouse pointer has a parent called mouse pointer. So when its constructor is called, its super is mandatory to be called, right? Otherwise, JavaScript will result in an error. The program will work, but it will violate the principle of constructor chaining, right? So we have to call the super constructor. And similarly, when this constructor gets called, now the JavaScript knows that this guy has another parent called super parent. So this also should call the super function here. Otherwise, this would again result in error. So now this entire chain, right? So the first the chain that we talked about, the parent, then it's all of its children, right? So it will go to the toppest parent, and then all of its children in the hierarchy will get executed one by one, right? So that is what is required, and we'll see it in action. Yes. So that is what it will happen. And let's say if I remove this guy, if I remove this in constructor invocation, the super invocation, then this chain gets broken, and it results in this particular error again. Must call super constructor in derived class before returning from the derived state, right? So that is what happens. So this is why we have to call this super constructor, right? So now that we understand, so just I would want to mention it again that these are two different, since the name is the same, but this is a super function invocation, and this is a super keyword to refer. So this is used with the dot operator. So dot operator is used to refer to the functions of the parent classes, whereas the super as a function invocation is used in constructor. So in anywhere else you cannot write this. This should not be written. This is not valid, right? This is not valid, but this is a valid constructor. This is a valid construct, and this is how it should be, right? This is perfectly fine. This is perfectly fine, and this is how it should be done, right? Now since we have mentioned this, another rule that comes up with using super in constructors is that the super should be used this particular super, right? It has to be used in your this particular super always has to be written in the first line of the constructor, right? Super cannot be written, super should not be written here. Super is always written in the first line of the constructor. Otherwise, it will result in an error. JavaScript will throw you an error that what are you trying to do? So JavaScript, and this is the rule, right? This is the rule, and this is because the constructor chaining principle will fail. Otherwise, if I put the super here, what would happen, right? So let's say I put it here and I put this here, right? So think about it. So what is it that would happen? What is it that it would result in? So let's say then it would result in that there are some initializations that I want to do before my parent class gets called, which is not correct, which can lead to unintended consequences. And I'll explain why I mean that there will be unintended consequences. The reason is that, let's say you are doing some initialization. So let's say we'll take this example of mouse pointer itself. And since we have understood this concept, let me just remove this. And we'll remove this also. Right. So now imagine the case wherein this particular super, right? This particular super, now this doesn't make sense. So this particular super, when it gets called, and if I what if I move it to here? Now imagine what is happening. Let's say you made some initializations here. Let's say you said this dot something, and you assigned some values, right? And let's say you did some initializations. But what if the parent class actually also has those initializations? The parent class also is making the same initializations for that particular same variable, or it's changing the value for that same particular variable. Now this will lead to unintended consequences. The reason is that your code will so the overridden class, overridden constructor will actually make some changes. But what if the parent class will actually revert those changes. Your changes will get reverted. So let's say I had done this dot x equal to 10. Let's say I had done this, right? And what if my constructor was also, and my parent class was actually assigning this value of x to be 100, right? So this in this case, and then whenever you are actually trying to refer it, so let's say when you were trying to refer and you are saying this dot x, right? So in that case, what is it that your expectation? The expectation should be actually x equal to 10. Okay. So the expectation in this case would be that x equal to 10. When you are accessing this, you are expecting a value because in your child class you have actually explicitly assigned the value of x as 10, right? This is actually what we have done, right? But now since we are calling super after the constructor, after our initializations, this would actually result in a value of 100, which is not correct. That is why super should always be called in the first line of the constructor. It is a rule, and it is also a convention. So that is, you can consider it as a rule or a convention, but that is how things are supposed to be. Otherwise it will lead a lot of confusion, and just to stop all of that, JavaScript will throw you an error whenever you don't invoke it super in the first line of the constructor. That's it. That's as simple as that, right? That is all about super, right? Also, just to give you an example of wherein some of the cases where just to give you an example of what is something that wherein you would require this kind of functionality of constructor chaining in case of functions, right? That you might require this, right? So let's say just imagine that instead of inverted, what I want to say, I'll say slow mouse pointer, right? Let's imagine this, and I'll say slow mouse pointer, right? Just imagine this, right? That we have slow mouse pointer constructor, right? Now, I'm not concerned about the constructor, so let me remove this. Here also not required. I'll remove this guy, right? And let's say I console.log, and I'll say mouse dragged left slowly, right? So this is something which I do. Now just imagine, right? So let's say that there were some calculations that were happening, and let's just say that there is some value. So let's say there was some value called x, and this value is this dot x equal to 10, right? Let's just imagine this value was calculated somehow, and blah blah, right? And there was also a value of y which is also there, right? And then we'll say this dot y equal to 5. And I just want to play around with the value of x, right? But I would want this now, now just imagine this, right? So when I do drag left, right, what is it that I'm doing? I'm doing drag left is then now initialize values of x and y, right? Drag left is actually initializing two data variables of the class and called x and y. Now when I am overriding this, what I want to do is that I just want to play around with the x value and not play around with the y value, right? I just to play around with the x value here of the mouse pointer, right? So what I'll have to do is that I want the y value to be initialized the way it is happening actually, right? So what I'll do is that instead of so in this case, if you can relate to the constructor example, what is it that we're trying to do? What is it that is actually happening, right? So what is actually happening is that we would actually want something of a constructor. We would actually want something of function chaining, that before this function gets called, before the function of this body gets called, I actually want to invocate the parent body of this. So to do that, we can do that. So now in this case, what will happen is that it would actually call the drag left of the function of the, it will call the drag left of the parent, drag left function of the parent, wherein it would initialize the x value, it would initialize the y value, and then I can play around with this dot x, and I can say this value, if I want to change it, I can change it to 8, right? And I can change it to 8. And then this value would be 8, right? And but the y value will actually be initialized to 5, what was happening in the parent, right? So how does this help us? This helps us is that we do not need to understand the entire logic of that was written inside the parent class. We are just concerned about the logic that we want to play around with. We are not concerned about the logic that is happening. We do not want to understand the entire code that was written inside the parent class. I do not have to know what are the initializations happening. I just want to know that I want to drag to the left a little slowly. So basically my x coordinate was 10. So now that I want to make it a little slower, what I can do is that I can change this value to 8, and then I will do it accordingly. And whatever value was in the y, I'll keep it as is, right? So I'll keep the value. I'll invocate the function of the parent, which is as is, and then I'll do this dot x equal to 8, which is actually changing the value of 8. So that is how this super keyword helps us here. and we are able to we have been able to achieve this constructor chaining kind of functionality with this in a function also. So these are just ways by which you can play around with your code and think about and think about what is happening, what are the various how wherein a super keyword is used, wherein a super function is used, why is it used, where basically and one very famous question that people ask is that what is the difference between this and super. So this is basically referred this is actually used to refer to the particular class. So when I say so if I find a variable z here, so to refer to z, right, I would have to do this dot z, but I would have to do this dot z, but to refer to the parent class, what I would have to do is that I would have to do this since this x is also we'll have to call super class, since they're referring to the super to the class. This is x is not defined in this particular class, so basically it will have to refer to here, right? So this will have to refer to x have to refer to the parent class. So that is why we'll have to use x here. But instead, when we want to refer to z, right, what we'll have to do this dot x, this dot z. So this is what we'll have to do for referring to z, because this refers to the current class, the class, the instance variables of the current class, where super is used to refer to the instance variable of the parent class. And this similar super functionality of super similarly applies to your static functions as well. So this exactly is a similar functionality. So we would not be going into depth for that, but that is what super is all about. And super is basically used to refer to the parent class. So super, just to give you just to end it, that super keyword is used to refer to the parent class functions and objects, whereas super function is used to refer to your constructor of your parent class. That's it. That's all about it, right? And we'll move to the next topic, which is constant values and enums in JavaScript, right? Let me just see if I've covered everything here. There's some issue which cool. We have live again. Yeah. Cool. So basically, what is it that we are doing? Let's consider some use cases, right? Let's consider some use cases of why are constant values required in JavaScript, right? So let's go back to our playground, and what we'll say is that let's define an object called const, and we'll say frozen object. Now let me just put some values A, B, C, D, and I'll come to what is the use case. First, we'll try to understand what's the use case for this. Why is it even required? And let's not put password. We'll put a hash key, and we'll say 1, 2, 3, 4. Let's just take it this way, right? Now imagine in your program you are referring to you're actually referring to some values, right? Let's say in your program you're actually referring to some values, and you want some constant values, right? So let's say in your UI or wherever you're using your JavaScript, what is it that you want to do? The thing that you want to do is that you want to display something like name and what the user has entered. So or let's say you want to say enter your name, and then you want to give a input box of some sort, right? And let's say that's what you want to do, right? So instead of and you want to use this enter your name in multiple pages, right? You want to ask a user in multiple pages that what is it that you want to do, and what is your name in multiple places. So instead of writing enter your name, let me give you a better example. Let's say this particular in this particular page, right? Now imagine that Newton School has a toolbar, right? This toolbar has a color of white, right? This whenever we open this website, it is always, whenever we open a new page in the website, it will always open up another toolbar with white toolbar, right? It is a white toolbar. But imagine that. But just imagine of a use case wherein tomorrow the designers of Newton School, they come up and they say that, okay, I want that this particular white, or we want to implement a dark mode, and in the dark mode, what we want to do is that we want to change the color of this as gray, right? So what is it that what we would have to do is that we would have to go to each and every and look at the code of each and every page, and then we'll have to see wherever white is written, and we would have to replace it with gray, right? This is something which we would have to do, right? But what when we're writing code, right, it is not a good practice to do this. So usually what we have something called as variable, and we have something called as color, right? And in this color we have white, and what we do is that we'll have something called as toolbar color, and we say this is white, basically. Right? So this is something which is happening, which is a very common use case, and then there would be multiple other just for the sake of simplicity. Let me just keep it as toolbar color as white, right? Now every time, sorry, in all the pages that I have to use, and wherever I'm defining a toolbar, what would I go ahead and I'll just do color dot toolbar color, right? And tomorrow whenever I want to see this, I want to do I can change this white to gray, and everywhere this particular function was getting used, this particular constant value would get changed to a value of gray. So that is what would happen, right? And that is what is expected, and this is a good practice, right, to define constants in your code, right? So now now this is a good practice, but the thing is that this particular field, right, now let's say this particular field color should be a frozen field, like nobody should be able to add or change these values, right? So if I say that these are my base colors, right? So let's say I have base color, I define it as a base color, and then we'll find it, and then you can have fun colors, right? Then you could put the playground, you could put some values, playground color, this would be black, or and could be this particular reset button, and this we could have reset button color, which is sky blue in color, or teal. Let's say it's teal in color, we'll name it as teal, right? So basically now these values, right, these values are something should not be changed, right? They should not be, so a developer should not come in and at some place, if the developer, I should not allow somebody to do the base color dot toolbar color equal to white, right? So now what would happen in this case? This is a very bad practice, right? What would happen is that let's say there were 5 pages in a website, and in the first 2 pages this was actually the color was gray of the toolbar, and then in some on the second page the user clicks on something, and somebody on that click, there's something called as base color dot toolbar color equal to white, right? And somebody did this. And now what would happen is that your entire color scheme would change all of a sudden, right? And all the remaining 3 pages would show white color, and the first 2 pages are gray color, right? This is not a good practice, right? It's a complete change in user experience or whatever, right? Just to give you an example, this is not a very good situation to be in, right? So basically, at some point of time, you would actually come across this situation wherein you would have to freeze your objects. All whatever is put into an object should never be changed, right? So JavaScript as a language provides us that feature by default. And what is that feature? It's called object.freeze. So object is class which is there in JavaScript. Freeze is a static function. That is why we have used it with the name of the class, right? So name of the class is object, and the static function of it is freeze. In this freeze, it will take a parameter of the object, right? And it is base color. Now, and it returns you an object which is of frozen type. Its value cannot be changed. So we can say variable, and we'll say frozen base color, right? And just I'll remove all of this. Now, whenever you do frozen base color, and we'll do frozen base color or toolbar color equal to white. And then let's see what will happen. Console.log of. Right. Yes. So basically, it was able to run this. And what is it that we saw, right? So even if we did frozen base color and we do toolbar color equal to white, it did not actually change the value. It should have ideally changed the value to white, right? But it did not. It did not change that value, and it actually resulted in as you would know, right? This would actually, and if I show you an example, name it temp, and we'll say temp dot key. Just to show you an example of what object dot freeze does is basically it will freeze all the values that are there in your ideal. So it will freeze all the values that are there in your object, and it will not allow anybody to change it at runtime. It will actually freeze it, and it will never allow it to anybody to change or play around with those values anymore, right? So you can also not add anything to this particular variable. So you cannot say frozen base color dot new color equal to blue, and if you do new color here, it should not ideally let you. That's not what frozen frozen is. It basically freezes the structure and everything related to your particular this thing, right? Whenever I did, so it did not allow, it did not even add a new color to my frozen base color, and it gives me a value of undefined because it did not know, right? It actually did not make any changes to my object or its prototype, right? So this is what object freezing is. Now I just want to talk about in a couple of minutes about what are the basic conventions of JavaScript, right? The basic conventions of JavaScript are that a class name should always start with a capital letter. So let's say any class name that you have, right? You would be seeing that whenever I'm writing a class, I would always start the class name with a particular variable with a capital letter. It's always camel case in nature. Similarly, all the function names should always start with a smaller case, right? So let's say you have a function called, you have any function, right? So a constructor is anyways is a reserved keyword, but if you would have seen, I usually name all my functions in with starting with small, and these are all camel case in nature. So what does it mean? The camel case is that the next letter without space, the next letter should be actually capital, so that it's easier to read also. And this is basically, this is something which will not break your code, or it will not throw any errors, but it actually is the programmer's mind or everybody around you, when they follow the same convention, right? When I said that object dot freeze, right? How was I able to know that this particular object is a class, right? So this object is a class because I know, because the O is actually capital in nature. So that is why I know that this is a class, and there's a dot variable, and then there's a function freeze, right? And it's small in nature, right? And if let's say there's some variable called object dot and let's say frozen, right? Let's say I create a class and I have a static variable inside it, right? I'll have a static variable inside it, and then I'll say I'll say I'll say let's say any uh, parent age. Let's say I say, right? So this is something which this another convention is that whenever you are defining your variables, or when you are defining constant values, it is a very good practice to actually write everything in capital letters, follow, and they're separated by underscore, right? That way I can always know. So whenever somebody is using parent, whenever somebody has written parent dot parent age, instead of going and checking inside the parent class, I can just imagine, okay, this would be a constant value. This is a value which will not change. So that is why this is a parent. This is why it is all capital in nature, and uh, it is separated by underscores. So that is these are some very basic conventions. There are a lot of conventions, and when you start deep diving into all of these constructs, it will be very easy for you, and you'll grasp them slowly and slowly. But still, for the understanding of what JavaScript is, this is I just wanted to mention a few of them. One more thing is that the JavaScript is a huge language, right? There are a lot of features around prototypes, and I'd really encourage. So in this particular course, we have not tried to cover each and everything. We have not tried to cover, not gone into depth, and gone into not gone into a lot of things. But one thing I would really want to show is that you can play around with your Chrome browser, right? So I'm using Chrome browser. You can use any of the browsers, and then when you click on, let's say you go to any of the websites, and when you click on this inspect, you would see this kind, something of this sort, right? And there's a console, and when you go to console, right, you can run your JavaScript code here as well. So you can do var a equal to 1, and then now when you say a, it will actually print the value of 1. So this is basically a console, right? And since everything in your browser, everything is running as JavaScript, you can easily go and play around with JavaScript. It's a very beautiful language, and this is you can see all of these. So right, this is all of these errors, right? So whenever all of this code was running, and since it was not able to load because probably I have poor internet connection, it was not able to load, right? So basically all the logs that we did, right? So anything that I do, right, in my console.log, whenever some developer has done console.log, all of those logs, or if he has done console.error, right? So if I've written, let me just get rid of this, and when I do, I can do greet afternoon and do console.error, right? I can do console.error, right? And then whenever somebody is doing this, right, this would actually result in something of this sort, that this is an error, and it will give you a line number followed by the file where this particular field was invocated. So that is how it is, and you can clear, and you can play around with all of these values, that you can define a variable obj equal to, and exactly what we have been doing, right? But the playground that is provided in the website is a very good tool, wherein you can go around and play around, and it gives you a lot of autocomplete functionalities. But if you've not been able to access it, this is a very good tool wherein you can go ahead and let me just do this, and now we can do obj, right? And it will give me, now I can do object dot freeze. I can do obj, and let me just assign it to some variable, and I can say temp equal to, right? And now I can do temp. Now I can do temp dot a equal to 100, right? But and now then I do console, or when I do temp, it did not change the value. So basically whatever we have been doing over here, right, it can also be done in your browser, right? And that is what I wanted to know. And it's a very beautiful language, and it's very and the reason why JavaScript has gotten so popular in this world is that it's very useful, and it's very accessible to everybody, right? And everybody is today anything, right? In your phone, in your mobile, in your laptops, everywhere, everybody is using a browser, right? And everything, and you're seeing more and more things are getting implemented within the browser. You see sheets, all of these things, right, are getting implemented within the browser itself. And JavaScript has to scale to actually the JavaScript has to be performant, it has to scale just to match everything, match all the things that are going on. And that is why a lot of people are coming up to learn this technology, and it's a very beautiful language to go on. There are tons of material available. Newton School is also there are a lot of other courses wherein you can go. And so this was just a brief introductory course of JavaScript, and there are a lot of deep dive courses in Newton School website itself, wherein you can go and learn about JavaScript. There are a lot of things that we haven't touched up, we haven't touched on, like object prototypes. I would have loved to done that, but in the interest of time, we have not been able to cover all of that. But this session, I'm ending this session just to hoping that I was able to successfully create inquisitiveness in your minds, and hoping that you would want to pursue and learn JavaScript into depth. And I can assure you that even I have, after so much experience, like 5 years of experience, I would not say that I have learned JavaScript complete. There are so many things that you can learn about, the way the compiler works, the way the interpreter works, the way the engine works, the way there are a lot of things about known as hoisting, how variables, how is the VM booted, all of these things, right? There are a lot of things that you can learn upon, right? So that's me signing off. And please do use the doubts forum to ask any questions that you think that, and the team is constantly looking into the doubts forums, and we will try to solve all of these problems. Thank you. Thank you, everyone.